Hey everybody, we're here to talk about an order in the world of snowflakes. So just a quick overview of what we're going to be talking about today. We're going to give you a quick introduction to Sourced. It's a company that Keiran and I work for. We're going to give you a quick update on the site that we're at, the problem statement on the site, what we did on that site a few years ago to introduce them to Puppet, and then what we did more recently to sort of extend and uplift the Puppet environment on that site. And once we've done that, we'll go through the results of what we did. So to kick it off, who are Sourced? So Sourced Group are a systems integrator based in Sydney, Australia, and we have a capability in North America. We've been in the game a few years now. Our main focus is financial services, but we have branched out into other areas as well. And our speciality is configuration management, automation, data management, and all that cool IT stuff. So we have a bunch of industry firsts. We're really proud of those, and we have a few major projects that are currently in flight that I'll let you read through. So who are we?
So my name is Keiran Sweet. My background is I used to be a Unix and Linux system administrator by trade. I'm a senior consultant with Sourced Group. I've been there about 18 months, but I've known the guys for some time. I've done a lot of Puppet in my time. I sort of started back in the 2008 days, which was a different beast than what you see today. It's come a long, long way. It's a great product, and all the Source guys really love it. So my background is also VMware and AWS deployments.
I'm Pedram Sanayei. I'm just a consultant at Sourced Group. My background is actually Microsoft and Windows technologies. My current focus is Microsoft Azure or Azure. I'm not sure what they call it in North America. I'm confused. It's called something. And I've been dabbling in Puppet for about the last year. So I'm going on the Windows Microsoft journey with Puppet, which has been an interesting experience. So, cracking into it. So Keiran and I are on site at a major financial institution in Australia. And Source have actually been on that site now for about 3 years. Yeah. 3 years. And just to walk you through the site. So it's a tier 1 financial institution. And for anyone that kind of works in finance or banking or those sort of areas, there's a lot that goes with that. So I wouldn't say it's like defense, but it's kind of in the same sort of area. We're taking care of people's money. So there's a lot of security and risk that goes around that. And the area that we specifically work and the area that we're specifically consulting in is this organization's self-service computing platform. So what the organization has done is they've built a horizontally aligned compute platform for all of the internal businesses within the group. So we provide platform compute services to these different groups, and they consume these resources from us. As far as we're concerned, we're kind of like a cloud provider within the organization, and we leverage downstream providers, whether they be private or public cloud. What this means is we have lots of different workloads running in this environment, and every individual workload, while they look like the same to us, they look like an instance running, the application running on there is unknown to us. It belongs to some business unit down the stream, and they do what they do with it. What we have to do, though, is we have to provide them an SOE, which is secured, which is pen-tested, which meets the group's security requirements, and then we need to on-sell that. So a few years ago, when this organization started their cloud journey, and they were very progressive in their Amazon journey, they started, I think, 4 to 5 years ago now, they selected a cloud broker to assist them with their integration into both their private cloud and the public cloud. And this broker has kind of evolved, and it supports VMware, AWS, and Azure. What this broker basically does is it interrogates the APIs of these cloud providers, and it creates instances. It deploys instances within these cloud providers, and it kind of manages the life cycle of those instances. So it gives users an ability to log in and say, I would like a server like this, and then it goes off to VMware or AWS or Azure, and it deploys that instance. What it then does is it goes into the instance and tries to configure an SOE, deploy an operating system, install an app, and it tries to manage the whole thing from top to bottom. And around all of that, it does a whole bunch of other stuff. It integrates with Active Directory, with your monitoring, with your security, and all your CMDB and all sort of your legacy systems. So what I would say here is that what we're about to talk about is more of a stateful, traditional compute environment where the instances live for a life cycle, they're commissioned, the application's installed, they're decommissioned, and they're disposed, and they live in the CMDB, kind of traditional compute. There is a talk by Source Group from PuppetConf last year, which talks about using PE in a stateless, sort of more modern cloud environment. So this institution has 2 ways of doing it. We're talking about the more traditional stateful compute in this talk. So to walk you through it, how is an instance created? So a user basically logs onto this cloud broker, and they select a bunch of settings. So most obvious is, what operating system do you want? Do you want Windows or do you want Linux? And I will say here that 70% of their fleet is actually Windows, and it's quite a large fleet. You select your service tier, sandbox, non-production, production. You say, where in the network would you like me to put this machine? Is it a secured machine? Is it running a database? Is it running a web server? Depending on where it is, it gets placed in the network somewhere appropriate. And then you move on to more specific configuration for the actual instance itself. Active Directory, which domain am I going in? Do you want backups? Yes, you want backups. What time would you like me to back up your instance? I'm going to patch you. What day would you like to get patched? And then it gets interesting. Then it says, which scripts would you like me to run on your instance after I've deployed the SOE? So I've deployed the SOE. Now I'm going to run a bunch of scripts for you. What would you like me to run? And then there's a bunch of environment variables that you can inject as well, which become system environment variables on the operating system once it's deployed. And this is done for each individual instance that is provisioned. Because there's a lot of options there, and there is actually a lot more options in reality. But what this basically means is it means that each individual instance is going to be different from the next instance. It might be the same, but we have to assume that they're different. And that's kind of why there's snowflakes. They're all kind of the same, but they're all different, which leads to the problem. This is sort of the workflow that the broker does to actually deploy an instance. The first thing it does is it calls the API of the provider. Whether it's vSphere, Azure, AWS, it doesn't matter. It calls the API, and it creates an instance. And an instance is born, and it gets given a name, and it gets stored in the CMDB, and a lot of stuff happens around it. But this is kind of how the operating system becomes the operating system. So it deploys the instance. Once the instance comes up, if it's Windows, it syspreps it, adds it to a domain, all that kind of cool stuff. And then it starts trying to manage it. And the way it manages it is it SSHs to the machine. And using some bespoke templating language, you create a bash script, which it then executes on the machine. And if you want to run PowerShell or something else, it SCPs the script down and runs PowerShell inside bash on Windows, on Cygwin, in 32-bit. And bad things happen.
It's the worst.
What happens?
Cygwin on Windows means you get shell shock on Windows.
It's great. So you can see we have a problem. The problem, it works if you like writing bash scripts for Windows, which is bad. So it became really evident that while this works, and the broker is kind of really good at the other stuff, kind of giving you an interface, giving you an instance, calling the APIs, it kind of does that really well. But there's a place here to do this better. This can be improved. So to run you through the problems, the broker only looks for exit 0. So it starts executing scripts in series, fires a script, gets an exit code, fires a script, gets an exit code. And if you imagine you're building an SOE here, you have a bunch of scripts, you're doing a lot of different stuff. If one of those scripts exits with a 1, it's over. So you've spent an hour building and patching your Windows machine, and one of your scripts to configure NTP or something fails, you just don't have an instance, you have to start again. The scripts are fire and forget, so it's very traditional in the way that it works. It fires a script, it gets an exit 0, that's it, that's the end of it. So what happens is you end up building all these instances, and they were all great when they were built, but as time goes on, they start to drift. And not only do they drift, you don't know what they've drifted, how they've drifted, you have no idea what's happened. So you're constantly scanning your machines and interrogating, which is just a traditional compute problem that Puppet was really there to solve. We talked about Cygwin. Please don't ever use Cygwin on Windows. If you do, you're cheating. It's the worst. Don't do it. And the broker, because the broker is now managing lots and lots of instances, you can imagine it's SSHing like to so many instances all the time. So it gets really, really slow. The other problem is the broker being like a one package that does everything. It has some CI/CD capability, but it's not as good as your Git or like your Atlassian story or any of those other CI/CD packages. So it has its own, but it's not great. You end up copying scripts a lot between the different environments, and it's much nicer to not have to do that. So what do? Source were engaged about 3 years ago, and we saw a place for Puppet here. What our real aim here was to sort of use the broker to deliver us an operating system, deliver us an instance, give it a friendly name and put it in the CMDB and do all that cool stuff, but then to drop a Puppet agent on it, get it signed, and then pick up its metadata and give it to Puppet, and then let Puppet do the work. So the real aim was here that we'll deploy an instance, the instance will get built, Puppet will come on the machine, Puppet will build it, and then the user has an instance which they could use. So what do? We built out a traditional Puppet 3 HA Puppet environment. We converted all those ugly bash scripts and PowerShell scripts to Puppet code. We wrote some scripts within the broker itself to deploy that Puppet agent, to approve that Puppet agent, and then we succeeded in sort of removing the broker's responsibility for the SOE and shifting that responsibility into Puppet, which is much nicer. There's a bunch of challenges with this, though. This was Puppet 3. It was more than 2 years ago now. The broker itself has all this information in its database about the instance, and we need that information to configure the instance. So the user said, I want backups. Well, we need to run the backups module on that machine. So we had to kind of get that information out of the broker. And the way we did it is we basically continuously scraped the broker's database, created a YAML file for each individual instance, and placed it on NFS. So back when we did this, we didn't have a whole lot of tooling that we could use. We didn't have a whole lot of Hiro backends. We didn't have R10K and all these tools. So we kind of used NFS and rsync and cron to kind of move this data between sites, and then had Puppet masters across sites for HA and using round-robin DNS. It was kind of a traditional sort of deployment, but it was really good for the time. And of course, we're using Puppet 3, and Puppet itself, Puppet 3 worked great on Windows, but we didn't really have that many providers. There was a lot of execs in our code. It worked, but it wasn't as pretty as it could have been. This is what it looked like. It was very neat. It was designed for, I think we spec'd it up for 500 nodes, so it wasn't going to be the hugest environment. It was active against 2 sites. We had NFS there. We had a little rsync song and dance. The cloud broker dumping its metadata into NFS. And we had a stash sort of CI/CD story sitting behind this. It all worked really nicely. What happened, though, is mum and dad had an extra 3,500 nodes, and now we have 4,000 nodes. We've extended this environment into other network zones, which may actually be in cloud providers. And now what we're doing is we're stretching NFS v3 across firewalls into cloud providers. We're quickly learning that replicating NFS across network sites is painful and bad. And it's starting to hurt, it's starting to creak, it's starting to break. And this is kind of where it started to hurt. So we had a few problems. The first problem was scraping this cloud provider and dumping out a YAML file for each node kind of worked really well. But the problem was when you now have 4,000 nodes, you have a lot of files, and it got to the point where you CD into the directory where the files are, and you type ls, and then you can just kind of take a nap for a bit while this just enumerates like all these files. NFS replicating between sites was not stable, so you come to work one day and it's broken. And because the Puppet masters are mounting NFS, the mounts have all gone stale, and the whole Puppet console has gone red, and it's not a good morning. And the same thing is happening across into other network zones. So we have like loads of firewall rules open to allow the myriad of ports you need for NFS v3, and it's all sitting behind round-robin DNS. So because we're not actually doing any sort of health checks, you're just getting bounced between Puppet masters, it's a lottery as to whether you're going to get a catalog or not. So what we did is we decided, well, we worked with the client, and we kind of agreed that it's time to sort of build a new environment. It's Puppet 3, I think we upgraded to 3.2 in the end.
Yeah, so we ended up upgrading it to 3.3.2 to baseline it in preparation for the kickoff of the next project. That brought all of the agents and everything up to a pretty solid level to move forward.
Yeah, so I mean, it was running an old version of Puppet. It was time for an uplift. We had all these problems. It had done its job. So we had succeeded in abstracting the SOE away from the cloud broker. But the customers wanted more, right? So at the moment, they would want to install their app. So they'll go to the cloud broker, they'll put in all their information, they'll get their SOE, but then they have to write a bash script to install their app on top of the Puppetized SOE, which seemed a bit crazy. And the customers were coming to us and saying, can we write Puppet code to install our app? And we just put in a little field to say, install Octopus deploy, or install SQL Server, or install whatever. So we kind of wanted to build it out like that. So as sort of a preface for the boundaries that we're working within, we already talked about this. It's a bank, so risk and security is number one. There's no sort of leniency there. The security guys push you. Wherever you can encrypt, you must encrypt. In transit, at rest, it doesn't matter. You encrypt. Authentication, role-based access controls, no-brainers. If you have access to the console, only people who need access to the console have access to the console, and they should only have access to those components of the console where they need access. Same goes for system access on the downstream systems. The next one is interesting: traceability, auditability, accountability. Everything needs to be logged. Everything, you need change control if you're changing the masters. Your CI/CD story has to be strong. You need code reviews. All that kind of stuff is important. And the last line is an interesting one as well. the organization is a very large organization, but the operations team is very, very small. And they look after not just Puppet, they look after the whole stack. So they're doing other stuff. They're looking after Windows and Linux itself. They're looking after the actual cloud providers. They're doing a whole bunch of other stuff. So they're not specialized at Puppet. They are smart dudes, but they're looking after a lot of stuff. So what we really wanted to do was build an environment where we could send them on Puppet training, and they could come back, and they could work in the environment. We didn't want to create a highly customized environment with an ENC and all sorts of things going on, that we send them on training, and they come back, and then we have to train them on a whole pile of internal processes around it. We wanted to build a Puppet environment that made sense to anyone who knows Puppet, might be a way of putting it. There's a few other sort of boundaries that we had. End users were to define the state of their instances. So we didn't want a situation where you go to the broker and you fill out that form that you saw before, and then you go somewhere else and put in more information. We wanted it all to be contained within the broker so the user experience doesn't change. We don't want the user to know that Puppet is doing things behind the scene. It all stays in the broker. It all remains contained within the broker. So the user experience and the training that users have had using that broker is retained. But importantly, we want users to define additional modules. So we want them to be able to write their own modules. We want them to have their own CI/CD story around these modules. And we want to use something like R10K to sort of bring them all together, make them available to our users. So when they're building an instance within this broker, they can say, give me XYZ module as well. And we lay that on top of the operating system. We did not want to couple the solution to the broker. So this organization does have a stateless, auto-scaling, modern cloud world as well. And we want to build this environment in such a way that they can come on board. The very legacy Unix and physical world can come on board. We don't want this to be a solution just for this brokered cloud environment. We want to build a solution that's leverageable by all the different parts of the organization. And lastly, we don't want to change this broker. So we don't have a remit to go in and put in a feature request to the vendor or deploy a new version or change the way. We want to fundamentally keep this broker the same, and it's not the game we want to be in. We want to be in the Puppet game, not the broker game. So we're going to work within the boundaries we're given. We're going to use the broker the way it is. This is what we did.
Cool. All right, so fortunately, Puppet Enterprise was to the rescue for this. There's a lot of really great features within PE when it comes to integration. First up, there's PKI everywhere. So we're talking about a bank. They want encryption in transit. They want encryption at rest wherever possible. They have a pretty aggressive data classification system around what is going across the network, and if it contains certain types of data, it has to be encrypted. In the case of Puppet, we were able, specifically Puppet Enterprise, we were able to solve a lot of these problems out of the box. So if you have a Puppet agent talking to a Puppet master, it uses TLS, it does strong auth via the CA. In addition to that, all of the other sort of microservices of PA all use a similar authentication and encryption model. So, connections from the console to the database, from the masters to the database and to other components, including the new node classifier API, all support. And as a matter of fact, in PE now, you have to use it for authentication. You used to be able to whitelist stuff and use the HTTP APIs. They actually mandate it. So you have to whitelist certs, generate certs for your endpoints and things. So straight away, that really helped us, and it also allowed us to just take the documentation for the product and give it to the security team and say, like, guys, they've got this, and you can, have a look at the boxes if you want, sniff the traffic, do whatever. But the problem was solved. So it allowed us to focus on the integration. In addition to this, we also had another challenge in our original environment, that we had a monolithic repo with all our code, all our hire data, and it was chock full of secrets. That meant that we really couldn't let people see the Puppet code that we had before, but it also meant that we really weren't encrypting stuff like we should have. Using eYAML now with Hira, it allowed us to break out everything into individual component modules, including hire data, and encrypt the secrets. So we're able to solve the issue with the security guys that we weren't really doing encryption as best we could, but it also meant that we could show all of the users all of the Puppet code and the hire data, including the encrypted secrets, so that they could make sense of it. So that was another thing that was fixed. Puppet-supported modules were key. It meant that people were building scripts and libraries with Cygwin, and they were like, oh, this team wrote like some wrapper thing, and someone else wrote a similar thing, and it was all a big mess. With Puppet-supported modules, we can provide those to the end users, and they just leverage a standard supported framework. mCollective and R10K really helped as well. It allowed us to remove the NFS mess that we had of syncing stuff everywhere. and it was really problematic. You kind of had eventual consistent puppet masters. Now you make a change in the puppet code, in your environment, things like that. R10K and M Collective sync it all in, and it's really great. And we've got like, across the dev and test environments and prod, we've probably got like 12 puppet masters that just are pretty much straight away in sync. The APIs are really great. We talk about them a little bit later, but being able to programmatically sign certificates, and that comes back to the security story of we didn't want people to be able to install a Puppet agent on a laptop and then just, pretend and masquerade so much that they were a server and get a lot of the catalog and have a look through it. So what we do is the broker actually knows what to expect certificate-wise for a new instance, and will only sign those. If you don't have a signed certificate, you're not getting a catalog. There's the whole node classifier story as well, which is new, and that's quite good, and we've played with that a bit. Right, how's this thing work? Cool, so we still had one kind of major problem space that we needed to solve, and that was that Pedram talked about we have all of this wealth of node-specific data associated with that node, with a different owner. There's very little grouping capability of the broker product, and we needed to fetch that data and evaluate it when generating a catalog for an in particular instance. So this was really the most difficult problem that we had to solve, and we had a bit of a journey to kind of solve it. Here's two things that we tried. So first up, you're probably all wondering, why didn't you just ask the broker specifically to give you individual node data? So we tried that. We tried it a couple of ways. One of the ways was that we used hire HTTP backend to query the REST API that the broker provided to say, hey, this node's checking in. I've got his fully qualified domain name. Please return all of this metadata about the instance. I know you've given it to me in XML. We'll deal with that after, and we'll evaluate it for the catalog compilation. So we used an ENC originally, and then we also tried a hire backend, which is really quite nice. The number of nodes I had on site now had hit sort of 4,000 nodes. It was a pretty busy environment. And when we load tested the API of the cloud broker, when it hit around the 5 requests a second level,
we had an outage.
We had an outage. So we found that the broker itself, if you tried to aggressively query it, it would fall over, which was less than ideal when we were kind of looking at requiring about 80 requests a second during peak time for check-ins. So that one was out the door. It was pretty frustrating. So we thought, look, we need to be able to get all of this node data associated with a node, and we need to be able to fetch it quick. So the next thing we tried was the new Puppet node classifier had come out in 3.7, and we thought, well, maybe we can use the node group capability of the node classifier to create a group for every single node and create them on demand when we need new nodes to be provisioned by the API, and that was quite cool. So what we did is we templated up some functionality to say when you create a new node in the broker, create a node group, push all of this metadata in as effectively top scope variables. Agent checks in, gets all its data, everything's good. That actually worked really well until we started pushing the 500 node group level. As you would expect, groups are great for grouping things. They're not great to have lots and lots and lots of groups with one node in it, with a whole bunch of attributes. Things kind of slowed down pretty quick. And we had a chat to Puppet Labs, and they kind of were like, yeah, you're not really doing the right thing here. Maybe you should try something else, but thanks for bringing it to our attention, and rightly so. It was a square peg, round hole kind of solution. So the next thing that we looked at was an externally managed caching tier. So what we ended up doing was being able to use the broker's functionality to execute snippets of code on certain events, specifically creation of a node, update of a node, save of a node, deletion of a node as well, to say, look, go through your tree of data about this instance, format it, and push it into a key value pair, a fast one. So we looked at some other products, but we had a design pattern for the firm already to use Redis, so we could use what they had already. And we're able to pretty easily extend it so that it would push all of its values in certain namespaces into a key value pair store. So we got the data into Redis. We were pretty happy with it, that it was pretty manageable. It's important to note that the cloud broker effectively manages this cache. It's still the source of truth. So if we lose the Redis cache, we repopulate it from the broker. And we're able to do that quite quickly. But now we have it in Redis, how do we get it out? Fortunately, well, we started looking at developing our own Redis backend for Hiera. A bit of Googling around, we found somebody had actually written one for us, so we didn't have to. So Reliant Security, who did a talk here a while ago, wrote a Hiera Redis backend that we could leverage. It's really, really, really good. I think I've seen a couple of people who used to work there and said thanks to them about it. We would have written it ourselves, but we don't need to. It's really, really fast. It's really reliable. And they use it in their use case is slightly different to ours. But yeah, it's really helped us. So now this is pretty much how our solution looks now, is that we're able to drop relatively stateless puppet masters behind GTMs. Relatively stateless, probably not the best term. Puppet masters behind an F5 GTM. And then all of the masters are then able to fetch their node data very, very quickly from Hiera Redis. I'm trying to remember what the next slide is. So in doing this, this is what the Hiera configuration looks like. So on the left-hand side, we see the backends that we support. So eYAML for our secrets, we put that first, mainly so that we can trump any value with an encrypted value if required. YAML up next for site-specific values, so LDAP servers, API endpoints, things like that, non-secret. And then finally, we have Redis, which is the node-specific data. And we put that at the end because we want the user's data to never be able to trump what we have further along the hierarchy. The hierarchy is kind of client-specific in a lot of ways, but we do have the node-specific stuff there first if we ever need to override things, and then working its way through operating systems here in common. Now, at the top, this is an example of how Hiera Lookup would traverse the backends and the hierarchy. So looking up config NTP servers, you can see it hits eYAML, goes through the hierarchy, goes through YAML's hierarchy, and then it finally hits the Redis key value pairs. Now, as you can see, really, we only ever hit the fully qualified domain name key value pairs to look up the node-specific values of that particular Hiera value. Now, I said it was fast. It's really, really fast. So we were able to get like 3 to 5 requests a second on the broker API. We've been able to benchmark Redis at 70,000 lookups a second on aging Opteron hardware. We couldn't break it. We were like logging in and just like renesting the process and trying to make it slow, and it was always really, really good. So we're kind of messing around. This is just like Redis Stat. It's a free tool. It's actually really useful for just keeping an eye on the cache and the lookups. But effectively, if you have a look, we use like 11 megs of memory. This actually contains all of the production, dev, UAT values for the whole site in there, 72,000 key value pairs. And then this is in our test environment. I kept all of the Puppet agents, probably in this environment, maybe like 30. And we saw that we're able to sustain peaks just messing about of over 500 lookups a second out of Redis.
This is on a 1 vCPU VM in our lab, which is running an AMD Opteron processor from 2010.
Yeah.
And we got to 4%, trying our best.
Yeah, so production's obviously a lot better. We don't expect to have any.
If you ever had thoughts that, don't want to put too much stuff in Hiera, it might get slow, you should put everything in Hiera if you're doing this, because it will never get slow. Everything else will get slow before this does.
So there's some cool tools to be able to benchmark it and suss it out as well. Are we looking for time? Cool. There's a couple of other things that this really enabled us to do in regards to wins. I don't know if you saw the talk yesterday about refactoring 200,000 lines of code. That was a great talk. We did a similar thing, but it was about 6,000 lines of code. We rewrote the whole SOE and functionality. And in doing so, we used parameterized classes. In doing that, it meant that using a Hira backend for this, all of our data about the entire site now comes from Hira lookups that we pass directly to the modules as parameters. We don't have to do top scope variables and things like that anymore. We have almost none. I think some maybe come from the console. But it also, through the integration, it also means that end users can set values in the broker and then look them up as Hira values for their own modules. So we don't have to have like, oh, users have top scope and we hit Hira. They just set their values in a set namespace. You might have noticed the config underscore namespace that I use in the example. That's one of the namespaces we push to expose it to Redis and Hira. In addition to this, one of the big problems we still had is how do we allow end users to add classes, Puppet classes? I want an Octopus server, I want some .NET, I know that there's a module for this, I want to add it, and associate it with their node. Fortunately, this was able to be solved via Redis as well. What we do is we've extended the broker, or we use its functionality to add some new fields, of which end users can add an array of additional classes. These get pushed into the Redis cache, just like you see here. So a fully qualified domain name of the node, and then Puppet user classes, and then an array. Now, what we do is when the SOE is applied via the catalog, we also say, if you see any of these classes, stick them in a user classes variable, and then contain it. So they also get applied as part of the Puppet run with the SOE at the end. So like it really, really solved our problem. We were still kind of scratching our heads on how we were going to solve that for a while. Cool, so results and gains. So just quickly, we've got some really big wins out of this. There's no more NFS and rsync magic. Everything's a lot more stable. Everybody's happier, or will be completely happy, which is great. The user config is enforced alongside the SOE. So one Puppet run, well, ideally one Puppet run. We'll do the SOE, enforce that, and also the end user's configuration. And the operational experience is greatly enhanced. So previously, we were actually using a custom ENC, which deauthorized the console. Was a bit of a problem. The ops team would log into Puppet Enterprise and like nothing really worked because we'd given authority to the broker and it was a bit confusing. With a Redis backend, it means that they can use PE like PE. They can go on training and it still works as expected, which is great. Scale and availability is also great. At the moment, we're running like 2 creaking Puppet masters for all these nodes. We're able to now scale them out and talk to Redis for any node data, which is great. And then security is also greatly enhanced through a lot more, role-based access control and things like that, but also all of the TLS stuff I spoke about before. The user experience is that now they don't have to do Sigwin. Instead, they can use Puppet modules and they can share it amongst themselves and not have the deep shame that comes with Sigwin. It provides a library of code. So we support pulling in Puppet-supported modules, which is great. So they can reuse that stuff and such. The classification, which I talked about in the interface, is identical for Windows and Linux. So you don't have to go do this for Linux and do this for Windows. Same field, same broker. And the last thing is the way that the Redis backend was written is that the broker is a strings only, only allows you to set strings only sort of variables. But what we can do is, because of the way it was written, you can actually put JSON into those values and reference those by pulling them in via Hira. So we can actually put in like a whole JSON configuration document into a variable, source it into the Puppet module through the integration, and then reference it directly in your application, which is pretty cool.
Cool.
That's it.
So we have some thanks and mentions. Obviously, the Puppet Labs guys who are not here. So Rob and Brett. So yeah, Rob and Brett specifically from the APAC region, but Puppet Labs as a whole. And also Gary Larissa, I don't know if you saw his talk before. Read his blog, buy him drinks, stalk him on Facebook. His stuff is amazing, helped us a lot.
And stalk him on Reddit now too.
Yeah, he's on Reddit now.
His username.
Superstar. Obviously, the guys and girls from Reliant Security, they did a really good talk in PuppetConf 2013. And they only have 800 views, which is a bit of a travesty. So go and watch their talk. I don't know why we put hyperlinks in this, because you guys can't actually click that. But just Google for it. And of course, our team mascot, Marnie the dog. So we'll throw it open to questions.
Cool. Cool. I think dude might come in your way. Bet you I know what this question is going to be.
Yeah, could you repeat who? I can't click the GitHub link.
The slides should be up soon, so you should be able to. But
Great, thank you.
To be honest, if you just Google Hiro Redis and it's Reliant Security, it's really, really good.
There's a question in the center of the.
Hi, great talk, by the way. Thanks a lot.
Thank you.
In a previous talk that I attended, there was talk about not using EXEs in conjunction with Puppet because it would break no-op mode and it would give all kinds of troubles with that. In Windows, and I didn't get the chance to ask the question there, so I'm asking it here. In Windows, it's mostly all EXEs and other stuffs, but
yeah,
how do you solve that?
So we just didn't use no-op mode before. That was how we did it. It was really terrible, but it was the only thing you could do. So just exec. But there's so many more providers now, and I know there's a DSE provider coming. If you're familiar with PowerShell DSE, and it solves 80% of the problem. So you can dramatically reduce the number of execs in your code, but it's just a problem that you have to deal with. But the Windows support for Puppet is really getting there, and once the DSE module becomes Puppet Lab supported, as soon as Microsoft creates a provider in DSE, it's available in Puppet, and you're very quickly being able to represent the whole Windows operating system as config. You're not execing DOS commands anymore. But yes, it is a problem, but it's becoming less of a problem as Puppet becomes more mature.
Yeah, I think it's worth noting that from 3.0 so we're actually moving to 3.8. We kind of just missed the 2015 launch, and it's taken us a long time to get here. Well, not that long, but just moving from 3 to 3.8, the Windows support has just really got a lot better. I'm a Linux guy by trade, and I rewrote most of the SOE. Obviously, Pedram helped, gave me some advice, but I was able to move a lot of stuff straight into the supported modules for Windows instead of a lot of the execs that we saw, and I was a bit like, thank God there's a new provider for this and things like that. So, I even myself, with a pretty rough Windows background, was able to move pretty fast on it.
If you combine it with things like Chocolatey as well, it gets even better. So there's other tool sets, not necessarily Puppet tool sets, that are outside that will actually help you. So you can just Chocolatey install package instead of having a big UNC path to a MSI. So there is other things outside of Puppet that will help you as well.
Cool.
Cool.
Oh, we got one more.
One down here.
Coming from the other side.
Hey, great talk, by the way. I was looking
Thank
forward
you.
to it. We have a question. We have some binaries that we have to get out to our Puppet masters. We distribute out to the agents from the Puppet masters. How do you handle if you have custom binaries and service packs and things like that you have to distribute?
That one's all you.
Are you saying binaries that you're installing on your nodes?
Yeah, they're like Adobe Experience Manager. We have some customized patches and things.
Yeah.
Nothing that we can download from the internet. It's something that we have to manage the binary of. Right now, we put them on our Puppet Master and allow the Puppet Master to distribute them out. I was just wondering how you handle that in a bigger environment.
Yeah, so we have, I want to say regions. We have 6 different zones where servers can be, and they have no network connectivity that way. So a single NFS share doesn't solve the problem. But we have an NFS export or share or whatever in each individual zone. And then in our Puppet code, we say, if you are here, your package is there. If you are here, your package is there. So we just basically, we replicate the packages around. If you're using MSIs, use Chocolatey, will make it easier. But yeah, we basically just have NFS repositories, and we just keep them in sync using rsync. It's not elegant, but that's Windows.
Okay, and totally unrelated question, if you need to bring 1 or 1,000 new nodes online, do you start with a generic Windows VM or generic whatever operating system VM, or do you have a custom image that you start with that's already connected?
So one of the features of the broker is it does image management for you. So what you do is you load it a vanilla Windows image, and you unpack it, you put Cygwin and Java on it, and then what it does is it runs a bunch of scripts on that image, and then repacks it as either a VMware template, an Amazon AMI, a Azure VHD, and then when you actually come to build an instance, it picks up that image and then builds it. So what that means is if you can combine patching into that process, because patching on Windows takes forever, if you combine patching into that instance and you do it every month, what it means is in the broker, when you go, give me a new instance, it builds from a patched image, which already has the preset things. If you actually use Packer, you can do this really, really elegantly in Packer. That's kind of the way everyone's doing it, but the broker has some capability to do that, which we leverage.
That's great. Yeah, that sounds like our process that we've built in-house. So
yeah, it's like the gold image or whatever you want to call it.
Excellent. Thank you.
Cool, thank you.